Alright guys, sorry, so I had to stop the video, so I'm doing a second part to finish off this A7, and then the other video was kind of the end of the A6 part 3. So this is just a continuation of that video that got interrupted. So in the last video I had done some square roots of negative numbers, but they were square roots, and that's why they were imaginary. This one is a cube root, and because it's a cube root, the negative here does not make this imaginary. It just means my answer is going to be negative. So to remind myself, I'm going to put a negative out front. So remember, an odd root will not have any imaginary parts if there's a negative under the square root. It's only if it's like a square root or a fourth root or something. Alright, so we're going to go ahead and break this down. I'm going to ignore the negative. I've already kind of dealt with it. I'm putting it in front to remind myself it needs to be there. And 250 is 25 and 10. Excuse me, 10 is 2 times 5, and 25 is 5 times 5. So again, I need 3 copies to bring 1 out, so there's 3 5s, so I'm going to bring a 5 out here. The 2 would have to stay inside. So I'm mainly just showing you this again as a review to remind you that if you have a negative under that square root or under the radical and it's an odd root like 3 or 5 or 7, your answer will just be negative. If it's an even root, like a square root, that's when you're going to have an imaginary solution. Okay? So now we're going to go ahead and we're going to look at some complex numbers. We're going to be doing operations with complex numbers. We're going to be adding them, subtracting them, multiplying them. So first of all, let's just kind of remind ourselves what an imaginary number is. So because of that square root of a negative thing that doesn't give us a real solution, I was kind of created to be the square root of negative 1. So because I is equal to the square root of negative 1, that means that I squared is equal to negative 1, right? If I square both sides of this, the square is going to go away. So I squared equals negative 1. So I encourage you to write that at the top of your worksheet for this. Anytime we see an I squared, as we're simplifying, we can replace it with a negative 1. Okay. On this one, we're just adding, so we won't be multiplying any i's together, so we shouldn't have any I squareds. But when you're simplifying complex numbers, you will never leave I squared or any I that's just bigger, like has a bigger exponent than 1 in your expression. So let's just quickly review. A complex number is in the form A plus bi, where A is the real part and bi is the imaginary part. Okay, so that's what a complex number is. It has a real part and an imaginary part. So here I have 2 complex numbers being added together. Here's the real part of the first one, and here's the imaginary part. On the second one, here's the real part, and here's the imaginary part. So I'm adding these. I can treat these exactly the same as adding polynomials. I can treat I like a variable, even though it's not actually a variable. It has a definition. It actually equals the square root of negative 1. So I treat it like a variable, but it's actually not a variable. It's an imaginary number. So I'm going to add negative 7 plus 8, because those are like terms, to get 1. And then I'm going to add 7i plus 7i, because those are like terms. So this would just equal 1 plus 14i. Now for a complex number, this is standard form. So the real part comes first, and the imaginary part comes second. So your answer should be in standard form. Okay. All right, let's try something else. Here we go. So on this one, I'm subtracting. So just like when I subtract polynomials, I need to subtract every term that comes after the minus sign. So think of it as a negative 1 and distribute it in here. So this would be 5 minus 7i. The first one stays the same, right? These ones change to the opposite sign. So this becomes plus 6 minus 4i. So now I'm just looking for like terms. I've got 5 plus 6, that's 11. And then negative 7i minus 4i is negative 11i. Okay, and that's already in standard form because I've got the real part and then the imaginary part. So we can add them, we can subtract them. Now notice there's nothing between the parentheses, so now we're going to multiply them. And we multiply them the same way we multiply polynomials. I'm going to start with negative 2, and I'm going to distribute it into the second set of parentheses. So negative 2 times negative 1 is 2. Negative 2 times negative 3i is plus 3i. And then I'm going to move to the second term, and I'm going to multiply or distribute it through the second set of parentheses. So 7i minus 1i is negative 7i, and 7i times negative 3i is negative 21i squared. So now we just need to simplify this. These two are like terms, so I can combine them. 3i minus 7i is negative 4i. And remember, I squared equals negative 1, so I can replace this with a negative 1. So this would just be negative 21 times negative 1, which becomes plus 21. And now these are like terms, so I can add those to get 23 minus 4i. Real part first, imaginary part second. Okay, let's go ahead and try a couple more examples. So here, I'm multiplying negative 8 by the complex number. Then I'm subtracting 5 times negative I. So we really need to be careful here with our order of operations. I do what's inside the parentheses first, but that can't be simplified anymore. So then I'm going to do multiplication and division as I work left to right. Once all the multiplication and division is done, then I will add or subtract. So the first thing I'm going to do is multiply this negative 8 into the parentheses. That would be negative 16 plus 56i. Then I've got a minus in here, and I've got 5 times negative I. So 5 times negative I becomes plus 5i. And now I'm just combining like terms. So these two can be added to get 61i. So just be really paying attention to what operations are being asked. That's multiplication because there's nothing between 8 and the parentheses. This one's times, and that one's subtracted. So you've got to do the times and the multiplication before you do the adding and subtracting. Okay, just like any time we're simplifying, we have to use our order of operations. Okay, on this one I have negative 8 times 7, which is negative 56. I've got negative 8 times negative 6i, which would give me positive 6 times 8 is 48i. And then I've got the minus in here. I've got 4i times 3, which is 12i. Now notice I'm putting parentheses here because this stuff is grouped together, and I want to make sure when I subtract that I'm subtracting this whole group, right? And then I've got 4i times 3i, which is plus 12i squared. And now I'm going to distribute that negative into the parentheses. I could have done it with this. I could have thought of this as negative 4i and multiplied both of these by negative 4i. That would have worked as well. So this will give me negative 12i and then minus 12i squared. And then remember, I squared, that equals negative 1. So this is going to become negative 12 times negative 1, which is plus 12. So now I'm looking for like terms. I've got negative 56 and 12, which is going to become negative 44. And I've got 48i minus 12i, so that would be plus 36i. All right, let's see what's next. So make sure if there is a squared here, anytime you've got a plus or minus in here, and you've got an exponent out here, I need to write this as negative 1 plus 5i times negative 1 plus 5i. That's going to remind me that both of these numbers need to be distributed here. So negative 1 times negative 1 is 1. Negative 1 times 5i is negative 5i. Now I'm moving to the second term, and it's going to get distributed. 5i times negative 1 is negative 5i, and 5i times 5i is 25i squared. Remember, I squared equals negative 1, so 25 times negative 1 is negative 25. So this would be 1 minus 10i minus 25. These two are like terms, so I can go ahead and combine them to get negative 24 minus 10i. All right, so now we're going to talk about something that is unique to complex numbers, and that is, well, I guess it's not unique to complex numbers because if we have roots or radicals in a solution, this is also true. But all complex solutions to, I guess, quadratic equations, although we're not really looking at those right now, are going to come in what's called conjugate pairs. So every complex number has a conjugate pair. And the way that a conjugate pair works is that the number, or the sign actually, that comes between the real part and the imaginary part simply changes to the opposite. So 1 minus 4i and 1 plus 4i are a conjugate pair. So if you're asked to find the conjugate of a complex number, you're literally just changing the sign of the number in front of the imaginary part. Okay, so let's look at a couple more. So I have 2 plus 4i, so the conjugate pair is going to be 2 minus 4i. So 2 plus 4i and 2 minus 4i is called a conjugate pair for complex numbers. So this one is pretty easy as long as you just kind of remember the definition is that if I have a complex number, I can find its pair by changing the sign in front of the imaginary part. So not the one in front of the real part, that one will stay the same. Just the one in front of the imaginary part changes to the opposite. Okay, so let's just quickly do one more of those and we can wrap this up. So this one is just I, so the real part is 0. I don't see it, so the conjugate pair would be I and negative I. All right, guys, try the assignment out, and if you have questions, let me know. You can email me or just come in and talk to me, and I hope you have a great day. Bye.